Thank you for this time. My name is Chugomana MD. We're going to look at PCP theory, that is topic 5, database application development. Now let me give you the overview of this topic. In this topic, you will be applying skills that we have learned in previous chapters. Now here you will be applying those skills in developing a database. Development of a working plan. Now, your working plan must consist of the following. There must be a project plan, there must be a project brief, there must be user requirements, there must be data specifications, there must be entities and attributes, there must be data relations, there must be technical specification. Now, all those things, whenever you are designing a database, they must form part of your working plan. That is the project plan, the project brief, the user requirements, data specifications, entities and attributes, data relations, technical specification. Now let us look at the project plan. Now a project plan or your project plan must include the following. It must include a list of tasks that needs to be done, who will do each task, an estimate of how long each task will be done. You must show the start and the end dates and the times of each task. All these tasks can be done at the same time as they are not dependent on each other. That is one thing that you must understand. All these tasks can be done at the same time as they are not dependent on each other. Now, when we talk of the project plan here, we are talking about how to manage your project. The project brief. Now, a project brief is a description or specification of what you are required to do. In terms of database design, a brief will deal with the following. It will deal with design, develop, test, and debug a database. Let me repeat this for the sake of effect. A brief is a description or specification of what you are required to do. In terms of database design, this will include the following. It will include design, it will include development, the testing of your application, and the debugging of your database. User requirements. Now, what is this user requirements, or what is it that you must include here in user requirements? Here you have to include user goals or tasks that users must be able to perform with your system, or statements of the user's expectations of the system quality. In other words, now here is where you have to include the expectation that the user is expecting from this particular system. In other words, what is it that the user is expecting from a particular system? Data specification. Now, in data specification, you must include the following. You must include data entities, data attributes, data relations. Now, what are these data entities? Data entities are tables in a database. The data attributes are the fields in a database. The data relations, these are the relationships between the normalized database in a table. In other words, in your data specification part, you must include all the things that are here. That is data entities, the data attributes, the data relations, etc. Data relations. Now, in order for you to retrieve information in different tables, you need to join tables together. Now, let's say, for example, you have 5 tables. One table has the names and initials of students. One table perhaps has the students' performance. Another table has the students' parents, students' guardian. Another table has the subjects that students are doing. So therefore, if you are in a table, table 1, where the table has the names and students, the names and the student name, student numbers of students, you must be able to retrieve information from another table. Now, how do we do that? We do that by means of relationships. In other words, tables must have relationships. Now, There are three types of relationships that are possible between tables in a database. We have a one-to-one relationship, we have a one-to-many relationships, and we have a many-to-many relationship. Now let me explain the different relationship. Now, what is the meaning of one-to-one relationship? One-to-one relationship means that a record in the table on the left-hand side is associated with only one record in the table on the right-hand side. One-to-many relationship. Right. One-to-many relationship means that a record in the table on the left-hand side is associated with potentially many records in the table on the right-hand side. In many-to-many relationship, this means that one record in the table on the left-hand side can be associated with more than one record on the right-hand side. Now, basically, this also means that one record in the right-hand side can be associated with more than one record on the left-hand side. Now, let us continue with explanation of relationships. Now, in reality, you shouldn't ever consider to have a relationship with many to many. In other words, many to many relationship must be the last option. Another thing that you should note is that an M to M or many to many relationship can be split into one to many relationship. Technical specification. Now, here is where you answer the question, what database application are you going to use? In other words, what are the technical things that are required for the application that you are going to design? In other words, here it's where you tell us that you are going to use Oracle, or you are going to use Microsoft Access, or you are going to use Fox Pro, you are going to use, so many, the names of different, databases. The purpose of a database. Now, what is the purpose of a database? The purpose of a database is the ability to store data permanently. In other words, when we talk of a database, we are talking about a storage that can store data permanently. It is a flexible way to store data to allow efficient updating and maintenance of data, to improve programming of data. These are the three purposes of a database. Functional specification. Now, what is it that you must include here in functional specification? Here is where you include the IPO tables. In other words, you must show us the flow charts, the IPO tables. In other words, you must show us a schematic diagram on how things are going to flow in your application. Keys in a database. We have three keys that must be included in a database. We have the primary key, we have alternate keys, we have foreign keys. Now, in the next slide, I'm going to explain the meaning of each. The primary key. Now, a primary key is a key that uniquely identifies each record. This key must be indexed. Now, what is the meaning of indexed? Index is a way of making sure that a field is able to access a specific kind of data. In other words, if, say, for example, we are using numbers as a primary key, this field must be able to access, say, for example, we have 2134. If there is another 2134, this field must not accept that. That is what we mean by indexed. But at certain stage, you are allowed to index this in such a way that it can be, access duplicate indexes. Alternate keys and indices. You can have more than one key in a table, but one of them must be a primary key. In other words, you can have as many primary key, as many keys as you can, but by law you are required to have at least one primary key. Now these other keys have names. They are known as alternate keys. In other words, alternate keys are other keys except the primary keys and the foreign keys. Foreign keys. Now what is a foreign key? A foreign key is a primary key in another table. In other words, if we have a ID number in another table, now we also have another ID number in another table. Now, in the first table, that ID number is a primary key, but in another in another table, it becomes a foreign key in another table. Join requirements. To join two tables together, you need to have a common field between them. The field must be a primary key in one table and an indexed field in another table. In other words, in order for you to join tables, there must be a primary key and the foreign key. And remember, there are those other keys that are not that important, the alternate keys. Advantages of joins. Now, what is the advantages of joins? They allow you to normalize data so that nothing is duplicated unnecessarily. They allow you to normalize data so that nothing is duplicated unnecessarily. Disadvantages of joins. The main disadvantages of joins lies in the need for the indices in both tables. The more the indices, the slower the database. That is one thing that you must note. If you have a lot of indices, what you must know is that the more the indices, the more the database becomes slower. Forms. One of the most useful database objects is a form. Forms are commonly used to enter data in a way that the integrity of the database is protected. In other words, forms are used to enter data, and they can do so in a remote way or straight onto a table. Ways to create a form. Now, how can we create a form? We can use an auto form. We can design a form using a form wizard. We can create a form in design view. Details of these and other stories has been covered or will be covered in practical periods. The difference between a simple form, a master form, and a subform. Now, what is a simple form? A simple form is a form that is able to manipulate data in one table. In other words, the form that you have been creating now and then, it's a simple form because it is able to manipulate data in one table. Now, what is the master detail form? The master detail form allows you to manipulate data in more than one table at the same time. In other words, a master table is able to manipulate data in more than one table, whereas a simple form is able to manipulate data in one table. A subform, this is a form within a master form. In other words, in a master detail form, if you can add another table inside a subform, inside a detail form, that becomes a subform. Query. Now, what is a query? Now, a query is a database object where we ask a question in a database table or from another query. In other words, with a query, we ask a question from a database. Now, the output of a query can be in the following ways. It can be in the form of dataset. It can be in the form of a form. It can be in the form of a report. You know, a dataset is a table like output. In other words, when you run your query, what you see is a data set. In other words, the results of a query is what we call a data set. Filters in a database. Filters are an excellent way of selecting and viewing subsets of your database data. In other words, in a database, you can sometimes, instead of using queries, you can use filters. Now we have three types of filters. There is filter by selection, there is filter by form, there is filter by input. Now how do you do that? In order to filter by selection, you scroll through a query results and manually select what you want. To filter by form, you choose the filter values from a list. To filter by input, you enter specific values or expressions which are then used to filter the data. Reports. Reports are similar to queries except for the following. A report has more formatting. They can be made to look smart and professional. They can be developed for reuse. In other words, you must know the difference between a query and a report. A report has more formatting, which means that a query doesn't have enough, has fewer formatting. They can be made to look smart and professional. A query is just a query. In other words, a query is a table like, in other words, it's a data set. It cannot be made to look smart or professional. They can be developed for a use, which means reports can be developed for a use. You can use the report several times, but a query is developed as is and used at a specific instance. Thank you for watching and listening to this video. Let us meet in our future video tutorial. Thank you.